Hi, everybody. I hope you had a good break. I did. It was my birthday on Labor Day, so that was exciting. Today we are going to do the magic tube from the Science Magic Tricks. And I already have it pulled up, but for a quick recap, you go to Google Classroom, Chemistry Experiments, you click Free Science Magic, takes you here. Sometimes it will show up at the top that you have to click allow, or you have to go to settings and allow Flash to open. But and this will only work on Chrome also. And if you can't get access to this, that's okay, because the videos have everything you need in them. And I will post the links to learn more in this section here, like I did with the leak-proof bag and the spinning match. So you don't have to worry about if you don't have access to this. All right, then we clicked Magic Tube, and that's how we got here. Okay, so today we are going to need a toilet paper roll. Tissue, I grabbed 2. A rubber band, I grabbed a hairband because I don't have rubber bands. Salt, I grabbed the cheap salt. And it says a wooden dowel. I grabbed a plastic spoon because it's round and I don't have a wooden dowel, but it will do the same. And it does say adult supervision. Remember to ask your parents before doing these experiments. And you technically don't need to be supervised to do it. You just have to have permission to do it. Okay, so we are going to set up the first tube without salt. So we take the toilet paper roll and the tissue, put the tissue over the toilet paper roll, use your rubber band to lock it in place. Oh, I broke my tissue. I have to start over. Okay, I just moved it in location. Okay, don't break your tissue. Otherwise, you ruin your experiment. Okay, trying this again. Come on, hairband, you can do it. All right, we got it. Okay, our setup is complete. Now we need to take our first tube over to somebody that we are considering our audience and have them push our spoon through the opened end of the toilet paper roll. What do you think is going to happen? The spoon went through. Okay. All right, so we know what happens if we just have the tissue over the toilet paper roll and we push the dowel through. Now we're going to fill a second tube with salt, or I'm going to use the same tube because I don't see a purpose in needing a second tube. And that's what I'm using my second tissue for. Put my second tissue over it, rubber band it. Okay, then it says fill it with salt. And now what do you think will happen if we push the dowel down into the salt? Okay. All right. Filled it with salt. I'm gonna turn it sideways without getting salt on my computer so you can see. Okay, what do you think's going to happen now? I don't think I filled it with enough salt, so I'm gonna put in more salt. Okay. Oh, yes. Remember, okay, so I haven't played the video for you yet because I wanted you guys to be able to guess first. So in the video, it said that we needed to tap the salt in the tube on the table a little bit. And I filled it over halfway full with salt. Okay. Now we're going to turn it sideways and try to push our dowel through. Oh, it took a while, but for me, it did end up popping through. I also had it on its side. Now, that meant that when I had it on its side, the salt tilted like this. Do we see how that caused a problem? Okay, so now we are going to try again, but this time we're not going to tilt it on its side. I am going to flip it over on a coaster, or put a coaster on the top, then flip it over so that way I can redo my tissue without losing my salt. Okay, I'm putting my tissue on a non-broken section. Redoing my rubber band. Now I'm gonna pick up my coaster, tip it back over, tap, 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 tap. Okay. Now we're gonna try doing it straight down. Not going through. Okay. Let me move this salt that I spilled from our third round. Okay. So now we are going to watch the video. You don't need safety glasses. Okay, I missed our question there. Why can't you push the dowel through when the tube is full of salt? All right. So we are going to go to our challenge question. How did filling the tube with salt keep the dowel from breaking through the paper? The first answer, the dowel plunger pressed the salt against the sides of the tube. All of the force was on the tube, not on the paper. The second option, the salt chemically reacted with the toilet paper to create a much stronger paper that could withstand the force of the plunger. And 3, again, it's magic. Okay, so how did filling the tube with salt keep the dowel from breaking through the paper? Submit your answer to the question, and then we go to read all about it. It says it's all about static electricity. Move me over. Okay. Magic tube. Believe it or not, you can make a tissue so strong that it cannot be ripped. Tissues are known for a few things. For example, tissues are soft and nice for blowing your nose. Tissues are not, however, known for their strength. Most people wouldn't be surprised if a common house fly could tear through a piece. In the magic tube strong tissue paper experiment, though we'll show you a way to make tissue paper nearly impenetrable. I don't know why those there, but we'll show you a way to make tissue paper nearly impenetrable. Okay, then there's our video. Here's our setup. You don't, again, have to sign up for more experiments. That is completely up to your parents. Okay, how does it work? It may seem obvious that a wooden dowel can easily push through a piece of tissue paper, but what changes when you add salt to the tube? The amount of force you push into the tube remains the same. We are still pushing the same dowel through the same toilet paper roll. It's a different tissue, but it's still the same type of tissue, and we're applying the same amount of force. So why is it not going through the second time? Okay. The amount of force remains the same. In fact, you might add even more force into the tube once the salt is added, but the tissue paper just won't budge. The key to the tissue paper's newfound strength is the addition of salt. The hundreds of thousands of salt grains offer much more surface area to dissipate the force you thrust into the tube. As the force spreads from grain to grain of salt and against the outside of the tube, the force is also spread across the entire area of the tissue paper. The increased surface area makes the tissue paper appear much stronger than before. So, what that said is we are now changing the surface area to be only on the tissue paper, and now it is on every single grain of salt and the tube itself, not only on the tissue. So because it's so spread out, it can handle way more force. All right, then it gives you a science fair connection and related products. Again, you don't have to get any of those. And that's all. So that means our answer to the question, our challenge question here, is the first one. The dowel plunger pressed the salt against the sides of the tubes. All the force was on the tube, not the paper. Yep, we got it right. All right, now we are finished with this science experiment. Go challenge your friends. See what they can do. Can they get it through? If you would like to give it even more strength, you can fill the tube all the way up to the top, and that will help you have more strength that the tissue can withstand from the force of the dowel. All right, see you next time.